Okay, so on our first one here, okay, we've got lithium nitride. Is that ionic or molecular? It's ionic, yeah. Okay, lithium is a metal. So I'm going to go lithium, which is a +1, and it's with nitride, which is a -3. So I'll have Li3N for that compound. Reacts with water. Now, you got a choice here. You can write, this can be done more than one way, but I would assume that most people probably wrote it this way, because in a replacement reaction, that's how I told you should write water. If you didn't, there's a second correct answer for this, okay? If you wrote it this way, what kind of reaction are we looking at? Double replacement. They're both ionic compounds, or at least I wrote water like it was, and I'm treating water like it's an ionic compound, okay? Now, in a double replacement reaction, all that's going to happen is the metals are going to switch places. So that means hydrogen lines up with nitrogen, and lithium lines up with hydroxide. Okay, those are both ionic compounds, so they both need to be dropped and swapped. Okay, hydrogen is always a +1 when it acts as a metal. Nitrogen is always a -3. So I'll have H3N over here, and this is a -1, this is a +1. So if I want, I can put brackets around that, but I don't have to. They're 1 to 1. Okay, everybody with me so far? Okay, so that's what my products should look like. If I want to balance this thing, okay, well, lithium and hydrogen are both 3s, and they have the same charge, so it doesn't matter which one I start with. I'll just start with lithium. There's 3 over here. Now there are 3 over here, but that gives me 3 hydroxides, so I got to go back over here and put a 3 in front of that, which also happens to balance my hydrogens, and now I'm done. Reaction's balanced. The other way you could have written this was like this. You could have written water like this, and if you did, you get different products. In reality, both of these things happen when you add lithium nitride to water, so either one of these would be correct, okay? And you would have said still H3N, okay? That still would have been one of the products, but the other product would have been Li2O, because you would have had oxygen acting as the non-metal in water. Either way is fine, okay? There's not a wrong answer to this situation, okay? Either one, actually both of those happen when the reaction occurs. All right, so when I want to balance that one, okay, I've got to pick 6 as my lowest common multiple, so I need a 2 here, a 2 there, a 3 there, and a 3 there, and then it should work. Okay? Everybody okay with that one? All right, how many people have done the second? Okay, let's look at the second one too then. Okay, powdered zinc metal. Fancy way of saying zinc, yeah. Zinc is reacting with sulfur when heated. Okay? What does sulfur look like when it's by itself? 8. All right, what kind of reaction is that? It's a synthesis reaction. So when I put those two together, zinc with sulfur. This is a +2, this is a -2. That compound's fine that way. Now I need to balance. Okay? So what needs to go in front of the zinc sulfide? 8, yeah. And then what needs to go in front of the zinc over here? Then we're good. Okay, I'm going to scroll down a couple more here. Okay, try 3, 4, and 5 there. All right, so for number 6, we have aluminum, and it tells you it's reacting in a single replacement reaction with hydrogen sulfide, okay, H2S. All right, so in a single replacement reaction, what is aluminum swapping out? What's acting as the metal in hydrogen sulfide? The hydrogen, yeah, the hydrogen is the metal there. Whenever hydrogen is listed first, it's behaving as a metal. So what that's going to produce is hydrogen gas, which is highly explosive, okay, and aluminum with sulfur. Okay, that's an ionic compound, that's a -2, that's a +3, so we would have Al2S3. Okay, now we got to balance that. Hydrogen already looks good, but sulfur is the biggest number. There's 3 on that side, there's only 1 here, so I'm going to need to put a 3 there. That gives me 6 hydrogens, 3 there will take care of that. And what needs to go in front of aluminum? A 2. Okay? So, hydrogen sulfide, highly dangerous gas. In fact, if you go into pipelines, drilling, or anything like that, working in oil field kind of related stuff, you have to get an H2S certification because it is a gas associated with natural gas and oil deposits. And it can be released in pockets when you're drilling. Okay? Not only is H2S highly corrosive, were you to inhale it, it would destroy your lungs, but it can react readily with other things to produce hydrogen gas, which is highly explosive. Okay? So it's a very dangerous thing. So you have to take special training, okay, and get your H2S ticket, okay, if you're going to work in oil field or anything like that. So just kind of a practical application of that compound there. All right, we'll do one more, then we'll go up and we'll get our Shrove Tuesday waffles here. Okay, potassium hydroxide. So potassium is K, hydroxide is OH. That's a -1, that's a +1, so that compound's good. Reacts with copper 2 nitrate, Cu. The Roman numeral tells me use the 2+ charge. Nitrate, NO3, that's a -1. So when we drop and swap, we're going to need brackets around the nitrate with a 2 outside. What kind of reaction is that? Double replacement. They're both ionic. Okay, so we're going to swap the metals. Copper is going to wind up with hydroxide, and potassium is going to wind up with nitrates. What do I need to do with both of those compounds? Drop and swap. Okay, they're both ionic. Okay, copper was a 2+ over here, so it's a 2+ over here as well. So that's going to mean brackets around the hydroxide. This is a +1, that's a -1, so that compound's fine. Now we just need to balance it. Okay, 2 is the biggest number. It's on both hydroxide and nitrate, so it doesn't matter which one I start with. I'm going to put a 2 here to balance my hydroxides. Putting that 2 there gives me 2 potassium. Go over here, get 2 potassium. That's going to give me 2 nitrates. There's already 2 nitrates over here. Good sign. 1 copper, 1 copper. Reaction's good. Okay? All right. Now, here's where we're going. Okay, I want to go over number 8, because number 8 is a little bit different. Like I've worded it a little bit differently. Okay? I kind of tell you one of the products in the question itself. It says, in making copper metal. You're making something, that's one of your products. Okay? So automatically we know, okay, that copper is one of our products. So we have copper 2 oxide, okay, 2+, 2-, and it's reacting with carbon. Okay? This is not a typical reaction, okay, that we would have, because carbon is kind of a non-metal. Okay? So the only way we know that copper is one of the products is because they tell us that here. That means that the only other thing that can be produced is carbon dioxide in that reaction. Okay? And most like processes that involve removing a metal from its ore, copper oxide is an ore, okay? Removing the metal from its ore usually involve reacting it with coal, okay, carbon, and producing carbon dioxide and removing the metal itself from the ore. Okay, so that's what's going on in this one here, okay? And then if I want to balance this, I can see that oxygen is the only thing out of balance right now, so I would put a 2 there, okay? And I would put nothing, and then a 2 in front of the copper, okay? And then I would be good. Hey, everybody okay with that? All right, that's kind of a different one. I wouldn't give you one like that on a test, just because it doesn't fit with the 5 reaction types that we've gone over, okay? All right, number 9, sodium, Na, reacts with oxygen. What do I have to remember about oxygen? Right. What kind of reaction is that? Synthesis. Okay, when they go together, Na with O, that's a +1, that's a -2. Drop and swap. How much molecular stuff have we had in these questions? Like very little, right? The carbon dioxide, that's like the extent of the molecular stuff we've had. That's going to be fairly true, but don't forget that molecular compounds need prefixes and things like that. Okay? All right, so we've got that as our products, and then we have to balance this thing. We would need a 2 there to balance the oxygens. and a 4 there to balance the sodiums. Okay. And then for number 10, okay, we've got copper reacting with silver nitrate. What kind of reaction is that? Single replacement, yeah. Okay, because we've got an element reacting with an ionic compound. In a single replacement reaction, the element swaps out the part of the ionic compound that it's like. Copper is a metal, so it's going to swap out silver. Okay, so that means I'm going to produce silver and copper with nitrogen. Now, I put this one in here because this has one of those little tricks that we have to watch for. Does copper have more than one charge? Does this equation give me any way to figure out what that charge is? So what do I do? Use the first one, right? Which is? 2. All right, so 2 plus, okay, we'd have CuNO3 2, which would mean I need a 2 there and a 2 there to balance. Okay, tomorrow, you're going to get an assignment sheet that has 30 reactions on it. Okay, there are actually 3 sections to it, so there's 3 groups of 10. Okay, here's what you're going to be asked to do, so just stop packing up and listen. Okay, in the first 10 questions, I have given you the reaction in formula form. You have to balance it. There's blanks in front of everything. Okay, so you just have to fill in the blanks to balance and write it out in words. Each one's worth 3 marks. Okay, in the second set of 10, I give you the full reaction in words. You have to write it out in formula form, identify the type, and balance. 3 marks each. The last 10 are strictly prediction, and they are written out in formula form to start. So you don't have the word stuff, you just have the reactants like that. You have to predict the products and balance the reaction. Okay? So, like I said, if you're really focused, okay, you should be able to get it, maybe get it done or at least be close and not have too much homework. Okay? The intent here is not to give you hours and hours of work at home to do. Okay? The intent here is to give you a chance to do some assessment in class. All right? Due date for that, I believe I made March the 12th. Okay? So you guys will get that tomorrow. I won't be here. Mrs. Branch will be here tomorrow. That's not going to write on the board. So she will give that to you, and she'll play my instructions. Okay? So I'll have a video there that is my instructions. Pay really close attention to the instructions, because I don't want you to miss out on marks because you missed the instructions and that didn't demonstrate to me what you knew. Okay? All right, so that is tomorrow. Okay, we're done.